Hi guys, it's Miss B here. So this is the first lesson that I'm going to be doing in this format for you guys. It's going to be uploaded to a YouTube link, which I'll make sure to say all of this on Google Classroom as well. So here we go. Let's get started on this. So this is lesson 15.1 about central and inscribed angles, okay? So Mrs. Cuevas stressed that we learn this vocabulary, okay? If you don't understand this vocabulary, it's going to make doing these problems very difficult because you're not going to understand what they are saying when they're asking you for a chord, a central angle, or an inscribed angle, okay? So a chord is a segment whose endpoints lie on a circle. So if we go down here to my examples, all right, I have a chord, and it's highlighted in pink that there are two endpoints. There's one endpoint on the left side of the circle and one endpoint on the right side of the circle. A central angle is an angle that has the vertex that lies at the center of a circle, okay? So here, this is the central angle, okay? So you see that the vertex, which is this, is right in the center of the circle. An inscribed angle is where the vertex lies on the lines of the circle. So here is the inscribed angle, and here's its vertex, which you can see is clearly on the lines of the circle. All right, so that's what those three things mean. Okay, so we're going to use that information to name the chords, central angle, and inscribed angles in this circle. All right, so I am going to find the central angle first. So here is the center, okay? So my central angle is going to be right here, okay, because that's the one that's facing out. So this is going to be angle AC, oh, and I forgot to label this as D, okay? So angle ACD, all right? So my inscribed angle. So here's my inscribed part of my circle right here, okay? And I also have an angle right here. So we've got angle ABD, okay? That is our inscribed angle. And then it's asking us to find the chords. So I've got two chords here. I've got a chord here and a chord here. So that's labeled AB and AD, okay? Or sorry, not AD. It's BD. I got distracted for a second. All right, so here we've got some more vocabulary. I know that this is introducing a lot of vocabulary, okay? So you need these to be able to complete the sections in the homework. So you need to be able to know these vocabulary words, okay? So we've got a minor arc. A minor arc is where the points are on or in the interior of a corresponding central angle, all right? So if we go down here, this minor arc, so here is our central angle. So the minor arc is right here, okay? That's our minor arc. And what this is saying that the measure of angle ACB is equal to the measure of the arc AB. Okay? So whatever this angle is right here, then the arc is going to be the same. You can also translate that if the arc is a certain angle, then the central angle is that measure as well. So a major arc is where the points are on or in the exterior of a corresponding angle, okay? So our major arc, here's our central angle. So it's saying that they're on the exterior, okay? So the exterior is not going to be where the minor arc was. It's actually going to be on the outside, and I'm going to try and trace this as best I can, okay? So this is a major arc, all right? So the formula for this is they say that the measure of arc ADB, okay, because it includes the points A, D, and B, is equal to the minor arc AB. Oh, sorry, hold on. Let me say that differently. It's 360 minus the minor arc AB. Okay? So the total circumference of a circle is 360. Okay? And so if we have the measure of angle AB being part of it, if we want to find the rest of it, then we can subtract the minor arc AB from 360. And then a semicircle. So a semicircle is right here, okay? So it's got half of a circle, all right? That's what a semicircle is. And this is equal to, so it's equal to 180 degrees. That's because it's half of a circle. So it's 360 divided by 2 equals 180 degrees. All right, so anytime you see a semicircle, then that means that it's going to be 180 degrees. All right, so now we're going to talk about our arc addition postulate. All right, so this is just saying that the measure of arc ADB is equal to the measure of arc AD and the measure of arc DB. Okay, so in pink, I'm going to highlight this. So this arc and this arc together make up the arc ADB. So if it gave us so I'll do an example over here on the side. So if they gave us values for our arc, okay, and they said that arc DB is, let's say, 68, okay, and then let me get my calculator really quick. If we said that this part of the circle is 68 and this is 112, okay, we can add these together to get the measure of arc ADB. So that would be 112 plus 68, which equals 180 degrees. And that's because this is half of a circle, what I've just drawn. All right? So that's just coincidental that this happened to be a semicircle as well. The inscribed angle theorem, okay? So the inscribed angle theorem is that the measure of angle ADB, which is highlighted in pink, is equal to half of the measure of our arc AB. Okay? So I'm going to do an example, but let's just say for this one that if our arc was measured at 64 degrees, then the measure of angle ADB, that's B, ADB would be equal to 32 degrees because it would be 64 divided by 2 equals 32 degrees. Okay, so now I made a couple of examples for you guys. They're not the same as the ones that are in the notes just because I didn't see the ones in the notes as being as beneficial as the ones that I'm going to make right now. So you can use the ones in the notes as well, but I wanted to do one specific to central angles and one specific to inscribed angles. All right. So I'm going to draw my first example. So I'm going to say example. Now, I'm not very good at drawing circles, so I hope you'll forgive me. Most of these will not be drawn to scale because I am not an artist. I'm doing my best while holding my iPad and hoping it doesn't slip. Okay. So, in here, I'm going to say that the angle ACB is 45 degrees and angle BCD is 67 degrees. And it wants me to find, okay, the measure of arc AB and the measure of arc BD. Okay, so it's asking me to find here and here. Okay, I'm going to make that a little clear that they're separate so that we're not finding the total. Okay, so since this is a central angle, I would say that this is 45 degrees as well, since this is a minor arc. So the minor arc is equal to the measure of the central angle. So I can say it is equal to the measure of angle ACB, which is equal to 45 degrees. And measure BD, the measure of angle of arc BD, is also going to be the same as the measure of the central angle, which is right here. So that would be the measure equal to the measure of angle BCD, which is 67 degrees. Okay, that is for central angles. I'm going to do one more example for that. Okay, so I've got this, and I've got my central vertex, got B. Okay, and I'm going to say that, this is A. Okay, and I'm going to say that my arc AB is equal to 78 degrees. and it wants us to find the measure of angle ACB. Okay, so since this is a minor arc, I can say that the minor arc is equal to the measure of my central angle. Okay, so this is equal to my central angle. So this would be equal to the measure of arc AB, which is 78 degrees. Okay, so these are my answers for central angles. Now I'm going to do 2 examples for inscribed angles, okay? So I've got this circle, and I've got this right here. We'll say this is C, this is A, this is B, okay? And it tells me that my arc AB, is equal to 62 degrees. And it wants me to find angle, the measure of angle ACB. So using the inscribed angle theorem, I can say that the measure of angle ACB is equal to half of my measure of my arc AB. Okay? So I'm going to say is equal to half of 62 degrees, which gives me a total of 31 degrees. So that is my answer for this example. And we're going to do one final example. It's going to look a little crazy just because of how it's drawn. So let me make sure I draw it nice and big. Got G, E. I'm trying to use some different letters here. F. So it's not completely straight. I apologize. And this is A and B. All right. So I'm given that the angle of ADB is 42 degrees. Okay. That's what they've given me. And they've also told me that the arc of E to F is going to be, it's going to be 74 degrees. Okay. So we're going to use the inscribed angle theorem. Okay, so it says that the measure of AB, let me get to a different color. The measure of arc AB would be 2 times the measure of angle ADB. Okay, so that would be 2 times 42, which would give me a total of 84 degrees. Okay, and so this is just saying, so I'm just reversing this theorem right here. The fact that the measure of angle ACB equals half of the measure of arc AB, I'm just reversing that and saying that the measure of arc AB is 2 times the measure of the angle, okay? So we're also going to find the arc EF. So they told us, we're finding the measure of angle EGF, and they've given us that the measure of angle EGF is equal to half of our arc. So the measure of angle of arc EF. Okay, so I'm going to say that this is half of 74, which gives me a total of, let me do this, 74 divided by 2 is 37 degrees. Okay? And that is the end of lesson 15.1. So you can give this a watch or a listen, and you can go take the comprehension check that is posted on Google Classroom. I'll talk to you guys soon. Have a good day. Bye.